Data mining refers to a broad set of activities and tasks that can do a lot of different things for us. Similarity measures gauge whether a group of observations are similar to each other or are close neighbors. Several techniques, including k-nearest neighbors and cluster analysis, rely on similarity measures to identify similar observations within a data set. Two measures that we use for this are the Euclidean distance and the Manhattan distance. The Euclidean distance is the shortest length of a straight line between two observations. Conversely, the Manhattan distance is the shortest distance between two observations if you can only move horizontally or vertically. The Manhattan distance gets its name from the street grid in Manhattan, which is one of the boroughs of New York and is very famous for having a fairly rigid grid structure to its street layout. So let's go ahead and calculate some Euclidean and Manhattan distances using three observations within Excel. So our Euclidean distance equation takes the square root of the difference between one observation and another observation for each variable, and then squares and adds them together. So we're going to calculate the difference between observation 1 and 2. We're going to calculate the Euclidean distance. So to do that, we're going to use the square root function, and then I'm going to throw in another bracket there so I can subtract my values for x1 in observation 1 and 2. So I will subtract 4 from 3, or I'll subtract cell B3 from cell B2. And I'm going to close that bracket and I'm going to square it. And then we're going to do the same thing for variable x2 within the equation. In this case, we're looking at C2 and subtracting B3 from that, closing the bracket, squaring it, closing that bracket. I'll hit enter, and now we see that the Euclidean distance between observations 1 and 2 is about 1.41. And we can do the same thing when we're calculating the distance between observations 1 and 3. Going to use the equal sign to indicate that it's a function. We're going to use the square root function. And in this case, we will now subtract cell B4 from cell B2. We're going to square that. And then we will add to that C2 minus C4. And we'll square that as well. And we'll close up those brackets. And here we find the Euclidean distance between cells 1 and 3 is 7.61-ish. And then if you want to take a stab at calculating the distance between observations 2 and 3, if you run the calculation, you should expect to find a result at about 7.21. So moving on to the Manhattan distance now. Similarly, I've listed the observations and I've produced the equation for the Manhattan distance. One thing that we anticipate with the Manhattan distance is that the output is going to be an integer. It's not going to have a long string of values after the decimal point like we often see with the Euclidean distance. So the numbers that we plug into the equation are very similar, but now we're looking at the absolute value and we are adding that absolute value for the different observations that we're considering to each other. So to do this, we want to use our absolute value function, so ABS. And we want the absolute value between observation 1 and 2 for variable x1. So that's 3 minus 4, or it is B2 minus B3. And then to that I will add the absolute value of C2 minus C3. And to that we find an answer of 2. So the Manhattan distance between observations 1 and 2 is 2, whereas the Euclidean distance is 1.41. If you're calculating both the Euclidean distance and the Manhattan distance on the same set of observations, it's important to note that the Euclidean distance should be less than or equal to the Manhattan distance. If you're finding that the Euclidean distance is larger than the Manhattan distance, from an absolute value standpoint, you may want to go back and check your calculations. And again, we'll check into the Manhattan distance between observations 1 and 3, and then I'll leave you on your own to calculate the distance between 2 and 3. Again, we're going to use the absolute value function, and from here I want to subtract from B2, B4, because now we're looking at observation number 3 as opposed to observation number 2. And same thing with x2, we're now subtracting C4 from C2. And the distance between 1 and 3 is calculated at 10. And if you want to go ahead and calculate the distance between observations 2 and 3 yourself, you'll know you're on the right track if your result comes out to 10. So hopefully that helps you work your way through calculating Euclidean and Manhattan distances. Keep going and hang in there.